So you're running Kali ARM on your new Apple Silicon Mac. You're using UTM, and you've hit that wall, haven't you? Burp Suite just staring back at you, screaming, browser not available. It is so frustrating, a total time sink. Well, today we're going to fix it for good, and we're going to do it by actually understanding why it's breaking in the first place.
And let's just get this out of the way right now. If you've been tearing your hair out, blaming your proxy settings, you are in very, very good company. This note from the source material just says it all. We have all been there. It feels like a proxy problem, but as we're about to find out, the real issue, it's hiding somewhere else entirely.
Here's our game plan. We're going to kick things off by redefining the problem itself. Then we'll decode what's really happening under the hood and lay out two clear paths to a solution. We'll walk through the most stable fix, step by step, cover all those common traps that can waste hours of your time, and then we'll finish with a simple mental model you can use anytime the stuff acts up again.
Okay, first things first. We have got to stop chasing the wrong target. The goal here is not just to make some error message go away.
Your win condition is not seeing that little built-in browser window finally pop up. The real win, what you're actually after, is a setup that's stable, where you can reliably capture all your HTTP traffic and seamlessly intercept trusted HTTPS traffic without a fight. You know, once we reframe the problem like this, the right solution becomes a whole lot clearer.
So if our goal isn't just about fixing the browser, what is the real problem? Well, that error message, it's basically lying to you. It's not really about the browser being unavailable. It's a symptom of something much deeper inside your specific virtual machine setup.
Okay, here it is, the big aha moment. This has almost nothing to do with your proxy. It is a launch chain problem. Think about it like this. Burp is trying to start its browser, but it's reaching for a tool it needs, like a specific Java component or a graphics library, and that tool just isn't there on the shelf. The chain breaks before it even gets close to the network.
And that broken chain? It usually comes down to one of these three culprits. First, you might have installed Burp from your distro's repo instead of the official installer, which can lead to mismatched parts. Second, the version of Java on your system might not be what Burp is expecting. Or third, and this is super common, you're running a minimal Kali image and you're just plain missing some fundamental graphical library.
This brings us to a really critical choice. How did you install Burp? Look, grabbing it from your distro's package manager is convenient, sure, but it can create all these weird dependencies, and when it breaks, you're not debugging Burp anymore. You're debugging your entire package system. The official installer from Portswigger, on the other hand, that's self-contained. It brings its own Java, its own components. It's just way more predictable and stable, especially on these ARM VMs.
All right, so now that you know what's really going on, you've got a choice to make. There are basically two ways to solve this, and which one you pick really depends on what you need to get done right now.
And the question you got to ask yourself is simple. Are you absolutely committed to fixing that built-in browser for the tight integration? Or do you just want a rock-solid, easy-to-troubleshoot setup that lets you get back to work in the next 10 minutes?
This slide really just breaks it all down. Trying to fix the built-in browser? Man, that can be a complex rabbit hole. You're debugging libraries, you're fixing launch chains. The alternative, using an external Firefox browser, is often called the adult choice on ARM VMs, and for good reason. It's stable, there are fewer moving parts, and you can honestly have it up and running in less time than it takes to make a cup of coffee.
So for the rest of this explainer, we're taking that second path. We are going to focus on the pragmatic, stable, get-it-done-now fix, configuring an external Firefox browser to play nicely with Burp Suite.
And here's the secret to getting this done fast. We're going to treat it as two completely separate problems. First, we prove the network path from Firefox to Burp is working. Second, we establish TLS trust so you can look at HTTPS traffic without a sea of red errors. Two distinct layers, two simple tests.
So for step one, let's prove that path. You're going to pop open Firefox's network settings. You'll set the proxy manually to 127.0.0.1 on port 8080. And then, and this is the key part, you test it by visiting a simple HTTP site. Not HTTPS, just plain old HTTP. If that request shows up in Burp's proxy history, boom, layer one is done. The path works.
Okay, layer 1 is solid. Now for layer 2, trust. With that proxy still on, just type HTTP burp right into your Firefox address bar. That'll take you to a page where you can download Burp Special CA certificate. Download that file. Then, dive back into Firefox's settings, find the certificate manager, and import that file into the Authorities tab. Now, this part is absolutely critical. You have to check the box to trust the CA for identifying websites. If you miss that checkbox, it's all for nothing.
And this brings us to a huge trap that so many people fall into. Firefox, you see, often keeps its own separate little book of certificates it trusts. You can install Burp Cert at the system level all day long, but if Firefox doesn't have it in its own personal trust store, you're still going to get HTTPS warnings. You always have to import it directly into Firefox itself.
All right, we have a working setup. But before we wrap this up, let's go over the common mistakes that send people down these wild goose chases. Knowing these will save you so much time later.
This slide right here illustrates what is easily the #1 error, not understanding your network topology. It's simple. If Burp and Firefox are running in the same little sandbox, the same VM, then yeah, 127.0.0.1, localhost is your guy. But the second one of them is on your host Mac and the other's in the VM, 127.0.0.1 will point to the wrong machine every single time. You have to use the actual reachable IP address.
And here are the other big time wasters, just to recap. We've got the wrong topology, which we just covered. We have importing the certificate to the OS, but not to Firefox's own store. Another big one is trying to test with Google or Facebook first, sites with heavy security that complicates things. Start simple. And finally, just forgetting to check for any proxy bypass rules that might be silently sending your traffic around Burp.
Okay, let's boil all of this down into one simple, reusable troubleshooting framework. This is the mental model you can take with you and use anytime your proxy setup starts to act up.
Always think in these 3 layers. Start at layer 1, the proxy path. Ask yourself, can I get a plain HTTP request to show up in Burp? If the answer is no, it's a path problem. Fix your listener, your proxy host, your bypass rules. Once that works, move to layer 2, TLS trust. Does an HTTPS page load without warnings? If no, it's a certificate problem. Go import that CA into Firefox. Only after you've nailed those 2 should you even think about wrestling with layer 3, that optional and often fragile embedded browser. This ordered approach is how you stop guessing and start fixing.
And I want to leave you with this last thought from the source material, because it really just hits the nail on the head. When your tools are misbehaving, it's not you. It's just a system that's out of order. By applying a logical, layered approach like we just walked through, you give the system order. You do that, and you solve the problem quickly. You get your evening back.